Good morning, class. Let us start with the next topic for today, that is standard form. In the previous two videos, we have discussed about the basics of exponent form. In the last video, we discussed about the laws of exponents and we applied each and every law on the various applications. Today, we will be doing standard form, which is the last topic. Before that, I need to ask you the question, what do you mean by standard? When we talk about standards of living, standards of life, what do you mean by standards? You might be thinking that standards basically rules, we follow the principles of our life, we follow. That's what standard is. I give you an example. For example, you are in deserts, right? Already you know that in deserts the temperature is very, very high. And in spite of that high temperature, the sun starts giving scorching heat. Scorching heat means again, the sun rays are scorching the heat. Yeah, very heat, very warm means they are giving, the sun is giving a very warm rays, very heated rays. What will happen? Now the situation will be against you. Though the standard of the sun is to give the rays, is to give us heat, to give us warmth, but still we are going against that. This is what standard means. Standard basically for us means the standard of living, the comfort that I am going to have in my life. Okay. Similarly, the standard form here means the comfortable form of representation. If we are representing exponential form in any form, what is the way of representing that? I give you a beautiful example of desert. If you are there in desert and you are already, the temperature is high, the sun heated scorches, the scorching heat again adds up and the things are against your standard. It means that is against your comfort. This is what standard form means. Hence we are having standard form so that we can comfortably, so that we can represent the things comfortably in a precise manner. So let's understand, what do you mean by standard form? It means that if any exponential or bigger number is there, we can represent that number into k into 10 raised to power n form, where k is, there is a rule on k. K is greater than equal to 10. K is greater than equal to 0. K is greater than 0 but less than equal to 10. It means k can be any number in between, right? It has to be 0 and it can be, and m is an integer. M can be an integer. Are we clear? This is what standard form means. So if any number is there, it should be represented in this form, k into 10 raised to power n, where k is greater than 0 but less than equal to 10. It means it can be in decimal form. Yeah, it has to be a positive integer. If negative is not there in that case, positive integer. What else? It can be a natural, means positive integer means natural numbers, but 0 is not a part, because representing 0 into anything is 0. So whole will become 0. That's why we are not considering 0. So natural numbers are parts. Any doubt anyone is having in this form? And m can be integer, means power can be negative also, power can be positive also. There is no barrier on that. So let's have this. Let's take the example based on this. Come to exercise 13.3, question number 3. Exercise 13.3, question number 3. Will do. Let's have question number 3. Express the following numbers in standard form. Exercise 13.3, question number 3. First part, 5, 0, 0, 0, 0, 0. Yeah, let's have this question. Now, here 5 is represented. I can take k as 5. 5. Now count. 1, 2, 3, 4, 5, 6, 7. 10 raised to power 7. I can write this as this form. This is standard form or not? So understand how I represent it. First of all, I have taken the number 5 as k. Then multiplication as per multiplication. Then it must be 10 raised to power something. 10. How many zeros? 1, 2, 3, 4, 5, 6, 7. 10 raised to power 7 is the answer. Any doubt anyone is having this question? Very easy, very comfortable. Next, 70 lakhs they have given. If I have to represent 70 lakhs, again 7 into 10, 1, 2, 3, 4, 5, 6. 7 raised to power 6 is the answer in standard form. Third question. Now, 3, 1, 8, 6, 5, 00, 000. Understand? 3, 1, 8, 6, 5, 00, 000. How do we represent? Now, see, I told you there is one rule. Understand this very important rule. When we ever write a k in decimal form, this is very important. If this is decimal, this is the unit digit before, and this is the digit after decimal. Do remember, before decimal, whenever will be represented, because this will be represented in decimal form. Because here only one digit is there, here also one. But here we have 5 digits followed by a number of zeros. So hence we are left with one option, because k value has to be greater than 0 but less than 10. If I represent this as k value is becoming greater than 10, which is not a standard form. For this value must be in this form. So hence what I'll do, I'll be writing it 31865. Okay. Now understand, I told you before decimal there should be only one unit digit, and after that it can have number of digits. It means where I should put decimal? Decimal must be here, right? So I'll put the decimal into 10 raised to power. After that start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 raised to power 9 is the answer. What I did, first I put the decimal. After putting the decimal, I counted the digit followed by a decimal, and that has been taken as the exponent. Are we clear? Very easy. Very easy form. So in decimal form, the number has to be the decimal. Before decimal, there should be only one place value or one digit only. That's what we can be called out. Next. Very easy again. Fourth part, 390878. Now there is no 0. How will you represent? Again in exponential form, in standard form, where should be a digit? Decimal should be here. Put the decimal 3.90878. And then 10. Start counting. 1, 2, 3, 4, 5. I can prove this is equal. See, if I remove the decimal, I'll be getting this is what I'll be getting on removing decimal. It's already 10 raised to power 5. 10 raised to power 5. If I represent in exponential form, 10 raised to power. Answer is same. It means they are both are same. If I represent, both are same or not. Hence, they are equivalent. So we can represent. Next. Fifth part. Now already decimal is there. This is also very interesting part to see. Already decimal is there. Now you might be thinking already decimal is there. What to do? But decimal should be here. Bring the decimal here. For example, I brought the decimal here because decimals should be here in the standard form. Now count the number of digits between these two decimals. So 3.90878 into 10 raised to power 1, 2, 3, 4. 4 is the answer. This is what we have to do. Take the decimal where we have to take and count the number of digits between the two decimals. That will be your exponent. Are we clear? Very easy rule. Very easy rule. Next, sixth part. 3908.78. Where should be a decimal? Decimal should be here. Right? How many digits between the decimals? 3. So we'll be getting 10 raised to power 3. This is what the answer is. Are we clear? Based on this question number 4, let's see the question number 4. Now the statements are given. Now I will request, the statements are very important because see the level. Distance between Earth and Moon is given, distance between Sun and Earth is given, the size of microorganism is given, the size of cell is given. So this all are factual information for you. Factual. Facts are given about you. This is very important because direct questions come in NTSC and Olympiad exam. That what is the distance between this? So if you have a time and if you have a good retention power, I'll request you to learn this. Though I'm giving you a very difficult task. For whom? Because those who are not able to have a retention power. But who are a good retention power, they must learn question number 4. This statement, the distance between Earth and Moon is 384,000,000 kilometers. So I can represent. So how I can write this? Question number 4, first part. I'll be writing the distance between Earth and Moon is in exponential form and standard form 384,000,000 meter. In standard form, decimal should be here. Put a decimal as it is 10 raised to power 1, 2, 3, 4, 5, 6, 7, 8, 8. This is what is the distance between Earth and Moon in standard form. So I can say the distance between Earth and Moon is 3.48 10 raised to 3.84 10 raised to power 8 meter. Are we clear? Standard question. Any doubt anyone is having? So we can do rest of the part as it is. The population of India was about this in March 2001. So hypothetical situations, a statistical information is given to you which you can use. Are we clear? Any doubt anyone is having? Question number 1, expanded form. Write the following in expanded form. Question number 1, first part I am doing. Expanded form. Basically, I told you there are 3 forms: expanded forms, standard form and usual form. Usual form, I'll tell you what is usual form. 270,279,404. This is usual form because anyone can understand this form. Even who is not expert in maths, who is not having any expertise in maths, even that person can understand. It's absolutely 2,79,404. He is able to understand. But if I write the expansion form, what do you mean by expansion form? You would have done this in the very lower classes also. In class 1 and 2 also you might have done this expanded form. That what we do, we actually multiply the number with its place value, right? We multiply the number with its place value. Let's do it. 4 is having 1's place. 0, tens, we always say like that, tens, hundreds, then we have thousands, then we have 10,000s, and then we have lakhs and so on, 10 lakhs and then crores, then 10 crores, then millions. That way we do. What we do, we multiply. 1 means what? Can I write 1 as 10 raised to power 0 because that is equal to 1. Tens means tens, so can I write 10 raised to power 1? 100, so can I write 10 into 10, that is 10 raised to power 2. 1000 means this, can I write 10 into 10 into 10 into 10, 10 raised to power 3. It means our purpose is to represent this in expanded form, in exponential form, having base 10, right? 10,000 means this, means 10 into 10 into 10 into 10, that is 10 raised to power 4. Lakh means this, means 10 into 10 into 10 into 10 into 10, that is 10 raised to power 5. Hence, this way we will be writing, and we will be writing in exponential form and using the expansion form. So, what I can do? 2, what is the place value? Lakhs. So, 10 raised to power 5. Plus 7, what is the place value? 10,000. Next, 9, what is the place value? 1,000. Next, 4 place value? 100. Then we have 0, you have to write place value 10. Then we have 4 place value 1. This is how we write the exponential, expanded form of the number. Are we clear? You will include this 0 also. You will not. Though we know that 0 into anything is 0, but you will not exclude this. You have to write. It's a standard form. At least every form should be visible. You know the rule. What is happening? Decreasing. This is what happening here also. Decreasing. We are going from lakhs to 10,000, then 1,000, then hundreds, then tens, then ones. That is what is happening. Here also the same thing is happening. But plus sign. Because this is what I think you would have done this. But only the change is this exponential form. Rest you would have done. Multiply with place value, you get the value. Clear? Now the second question is the reverse of this. Now the expanded form is given to us and we have to write it in usual form. Standard form is given to us. We have to write in usual form. Let's do it immediately. Very easy to do. Let's do it. Question number 2. Find the number from each of the following expanded form. Expanded form is given to us and we have to find the number, means usual form. We call it as usual form. I'll be taking B part, question number 2. 9 into 10 raised to power 5 plus 2 into 10 raised to power 2 plus 3 into 10 raised to power 1. Now, only 3 digits. You might be thinking the answer is 9, 2, 3. Yeah, you might be thinking. Because 3 digits are 3 digit number. 10 raised to power 5. It means lakhs, hundreds, tens. Then what about 1,000 and 10,000 and ones? Because lakhs, it means the answer should have 9 lakhs. Absolutely 9 lakhs should be the value. 9 lakhs, 203. How to represent? It means, if I talk about this question, it means 10,000's value, 1,000's value, place value, and one place value number or digits are missing. It means they must be multiplied with 0. Then only they would have accepted, because anything multiplied with 0 is 0. So can I write 10 raised to power 5? It means plus 0 into 10 raised to power 4 plus 0 into 10 raised to power 3 plus 2 into 10 raised to power 2 plus 3 into 10 raised to power 1, 0 into 10 raised to power 0. This would have been the representation. But since these are missing, it means their digits are 0. Hence, what is the answer? 9, 0, 0, 2, 3, 0 is the answer. Hence, answer is this, not this. Are we clear? So, this is not the right answer. This is the right answer. Clear? Anyone with the doubt? So, if any place value is missing, it means that particular place value is multiplied with 0 as a digit. Clear? Any doubt? With this, your chapter exponent and power overs here only, and next chapter that we'll be going to start is algebraic expressions. Till then, take care, and I hope you would have learned a lot in this chapter. And this is very basic chapter and very important. Be thorough and please practice this chapter from other books also. And in case if you face any problem, feel free to contact. Till then, take care and bye bye.